All right, hi everyone. My name is Christina Tiss. I'm a project engineer with TRC. I work on our single-family residential building decarbonization programs for state energy offices and utilities. I also have JJ Swicky. You want to introduce yourself?
Hi, I'm a project manager with TRC, and we help implement a lot of the NYSERDA programs. One of the programs which is part of, which is introducing this presentation, is the Clean Heat Connect program, which supports contractors through the distributor and manufacturer network. We work with the upstream partners to help all the downstream partners improve on installation, sizing, and designing. With that, I'll turn that back over to you, Chrissy. And
Yep.
we are going to be doing a dual presentation on this.
Yeah.
Chrissy will present halfway through. I'll present almost to the end, and she'll pick back up and close it out.
Yep. And so today we're going to be talking about residential building load calculations and why it's so critical to right size with a cold climate air source heat pump, focusing on oversizing, why you don't want to oversize with the heat pump. So just to kind of lay out what our presentation is going to cover, we're going to talk about why it's important to conduct a load calculation, when you should be doing a load calculation throughout the process. We also spoke to some contractors to get their perspective on load calculations and why it's so important. We're also going to talk about building assessment tips and tricks for when you do that initial walkthrough of the home. We're going to talk about load calculation quality control and some sanity checks you can do when you finish the load calculation. And we're going to talk about software programs. So just to start off, what is a load calculation? A load calculation is a method for determining a building's heating or cooling design load, which represents the heat gain and loss of a home or building. The design load is determined by how well insulated the building is and in what climate it is in. It represents the amount of heating or cooling capacity that is needed during peak heating and cooling season for a home to keep it comfortable. So a proper load calculation is performed in accordance with the Manual J procedure. It's required by national building codes and most state and local jurisdictions. Manual J is the national standard for producing HVAC equipment sizing loads for residential applications. If you're not familiar with ACA, ACA is the National Trade Association for furthering the interests of HVAC contractors in the broader industry. So if you're a contractor performing residential load calculations, everyone should be familiar with the ACA Manual J standard. It's important to understand that every home is unique, and a properly performed load calculation that accurately represents the home is one that takes into consideration all of its unique requirements. So what does this mean? It means that you can't use any rules of thumb. So rules of thumb should especially not be used to size heat pumps. They were commonly used with sizing fossil fuel fired equipment or traditional AC systems, which was still in fact wrong. You might have heard of the old school 30 to 60 BTUs per hour per square foot or the 400 to 600 square foot per ton. What's so key about this is that the rules of thumb don't account for any of the building's features that have an impact on the heating and cooling loads, like the volume or the air tightness or insulation levels or window U values. You're not considering that when you use a rule of thumb. So when you think rule of thumb, think thumbs down. So what often happens when you use a rule of thumb, we often oversize the equipment, which especially when it comes to heat pumps is going to make not things better, it's going to make things worse. Oversized equipment, whether it's a heat pump or a fossil fuel fired piece of equipment, it's going to cause excess wear, decreased comfort, reduced efficiency, poor part load performance, and excess expense for the homeowner. Load calculations are performed to meet already the 99 percentile worst case conditions, so it's already oversized for mild conditions as is. So why take the time to do an accurate load calc when it comes to a heat pump? So oversizing, it's going to cause low load cycling, purge cycling, dehumidification issues, leads to discomfort, high energy use, high bills, shorter equipment life. You also don't want to undersize because it's going to lead to a lack of enough heating capacity during freezing conditions, over-reliance on backup heat. And overall, like, you want to right-size your heat pump. It leads to positive public perception of heat pump technology and more business for all of you. It leads to fewer callbacks, reduced wasted time, reduced contractor time, addressing those callbacks, and resources and money. So think of these pictures whenever you're doing a load calc. All right, so now that you know how important it is to do a load calc, does it make sense to do a block load or a room by room load analysis? So a room by room load analysis provides heating and cooling loads for individual rooms or zones. A block load analysis provides the heating load and the cooling load for the entire building as a whole. Most whole home full load heat pump systems are going to be multi-zone systems, so it's always wise to do a room by room load analysis. You might come across that the totals may not always be the same if you're going to check and do a room by room and a block load. That's just because square footages might not always match, and peak heating or peak times of the day for cooling load are going to be different depending on the room. So that's just another tidbit fact. But really, we recommend always doing a room by room load sizing analysis for heat pumps. So let's talk about the proper order of operations. So first, before sizing and installing a heat pump, it's always best to upgrade the home by air sealing and insulating first. And then after you've reduced the load is when you can perform the load calculation and install a heat pump. So most contractors should be able to do, simple air sealing measures like caulking and weather stripping, but you really want to partner with a home performance contractor to really get that load down, or add that portion to your business if you can. It leads to overall, once you're reducing the load, it leads to easier sizing when it comes to the heat pump, easier distribution planning, more balanced heating and cooling loads, lower cost, and better comfort. So talking about proper order of operations, would actually, before number one, would be air sealing and insulating the home, bringing that load down, then assessing the home to capture all of the building information to perform the load calc, conducting the load calc, getting that customer an accurate quote, and then installing and commissioning a right-sized system. And then hopefully along the way, later in the process, after you've properly sized the equipment, is when you're applying for the incentive application. At points in the program, as the quality control service providers for the New York State Clean Heat Program, we've seen that some contractors out there are actually performing the load calc later on in the process, just before the incentive application. And they were originally just installing a like-for-like system based on what the original equipment was sized to, or using a rule of thumb, which is going to lead to an oversized piece of equipment and uncomfortable conditions and, poor public perception of heat pump technology. So you want to make sure you're conducting the load calculation at the beginning of the process. So this is all great for people like me and JJ to talk about why you should do a manual J, do a load calculation. It's one thing for us as the program implementers of these programs to say that, but it's another thing to come from other contractors talking about this. So we did interview a couple contractors to kind of understand why they think it's so important to do a load calculation, an accurate load calculation, and how they do it while still doing the process efficiently. So we interviewed 3 that we know from the New York State Clean Heat Program provide accurate load calculations. And The main reason that they said that they perform accurate and take the time to do an accurate load calculation is because it produces more accurate quotes and it leads to higher customer satisfaction. We also asked them for some tips to make the process quicker and faster while still producing an accurate load calc. Tip number 1, they said visit the site initially to provide an initial quote while still collecting all the data for the complete load calculation. Then base the initial quote on a first pass that is less detailed than a complete load calculation. Tip 3, quotes based on that first pass should be contingent on a complete load calculation, and the homeowner should expect for it to be updated later on. Tip 4, during that initial walkthrough is when you should be capturing building details and taking photos to save time. Taking photos is huge for building load calculations. Ask the homeowner about existing comfort issues and pay close attention to spaces with hot and cold spots, humidity, distribution issues, and air quality issues. So for that, we asked them what helpful tools they use to kind of make this process efficiently. For that initial first pass, they are using, quick and easy load calculation websites like Easy Heat Loss or loadcalc.net. They also are using and taking advantage of those house scanning applications like Amply or Conduit to make this process efficient and faster. They also look up information as much about the house as they can ahead of time on real estate websites such as Zillow and Redfin. They also emphasized how important it was to use a blower door to capture that infiltration estimate. One contractor said that from start to finish, once they have done the whole process, set up the equipment, measure air infiltration and take it down, it really is only about 30 minutes per house. And they realized how important the blower door was when they did that initial first pass of the load calculation, and then they did a blower door later. They found that probably 40% of the time, the first pass air infiltration estimate without a blower door is off by more than 400 CFM, especially when it comes to older homes. So just from doing these exercises, they realized this is worth the investment. So how long is this all going to take? This is a time-consuming process. I'm trying to run a business. So they estimated that the first pass ranges from 15 minutes for simpler projects up to 90 minutes for larger, more complex projects. They said the data input for the full load calculation actually takes even longer. It can range from 20 minutes to a really simple project up to 3 hours for a more complex project. We also asked them what team members are doing this, who is doing the load calculation. The first contractor said all new hires are trained internally to perform load calcs, and the trainee goes out with an experienced coworker to shadow and see multiple example projects. Contractor B, sales team takes the photos, captures the building data, and then a more experienced employee is conducting the load calc. And finally, contractor C said the sales team does the whole thing. So whatever your process is, just make sure that whoever is capturing the photos, doing building takeoffs, and using the software, they really understand how critical this is in the whole process. Okay, let's talk about assessing the home. So as mentioned, surveying a home to gather information to perform the heat loss gain calculation can be time consuming, but it is time well spent when it can save money, equipment life, improve comfort, and conserve energy. When assessing the home, you want to understand what the building envelope is. So the building envelope is the barrier between the conditioned space and the non-conditioned space. It can be made up of the foundation or floor, roof or ceiling, walls, windows, doors, and other insulating surfaces. So you want to understand that barrier to make sure you're capturing all that data for the load calc. So when you're capturing data about the home, it's really good to understand what's going to have the highest impact on your load calculation versus what might be okay to not get 100% accurate. So What matters most for a residential heating load calc in cold climate regions like New York State, from highest impact to lowest impact, you want to make sure your design temperatures are accurate, your infiltration estimate is accurate, your window areas, your U values, and your ductwork are going to have a much bigger impact on your load calculation than, say, the doors. There's only, typically 2 doors in a home, small square footage, small area. Those are the ones you want to make sure you're taking the time to get accurate building information, take good photos of. Next, while a whole home cold climate heat pump in New York State is sized per the heating load based on ACA Manual S, conducting a cooling load calculation and ensuring accurate inputs for the cooling load is really just as important. So for cooling, what matters most for a residential cooling load calc in cold climate regions like New York, your design temperatures, your windows, the area of the windows, the exposure directions, the U values, solar heat gain coefficient, if there's any shading, and internal gains. Those are going to matter, again, the most for a cooling load calculation compared to, say, your doors. All right, I'm going to pass it off to JJ to cover building assessment tips and tricks.
Thank you very much, Chrissy. Hey, so better tools are always welcome. Better tools do equal better load calcs. Using a blower door to really get infiltration. Make sure you're using infrared thermometers. Always have a flashlight. Using a camera that can actually capture the details. So getting that good information so that the load calc can actually be performed correctly. All right. So find out, find out what the homeowner already knows. To do this, send out a survey to the homeowner. Get that information before even going to site. Emailing the homeowner to ask for construction drawings, year the home was built, or major renovations, upgrades to that home. Building upgrades, renovations completed since construction. Building square footage, and if the basement is part of that envelope. Products submittals or cut sheets for any windows. If you're like me, I save the NFRC sheets, so if you ask me, you'll get it. Insulation tape thicknesses, R values, U values, if they have that, all that information. Right. Use the right design temperature. For cold climate areas, we design for the 99% heat load and the 1% cold load, always focusing on the heating, outdoor dry bulb temperature, and the outdoor dry bulb temperature for cooling, with the humidities of 45, 50, and 55%. If you're in the New York State Clean Heat Incentive Program or the Empower Plus LMI program, there are requirements, and they do double check that to make sure that you're using correct data and temperatures. Make sure you approach the building for tightness. Blower door testing. Contractors are always encouraged to conduct a blower door test. It will give you the most accurate infiltration on the building and provide good input for the Manual J. The Manual J software tool is designed for that. You can then enter air leakage rates of the home into your Manual J and get a better Manual J result. Okay. So what matters most when it comes to windows? Windows area is one of the biggest things that impact heating and cooling. The U factor comes second, and then your solar heat gain coefficient is for cooling only, not heating. Still should be done even in states like New York where we're cold climate. And this will help determine how the heat pump will operate during the cooling season. Number of panes, framing materials, and glass coatings impact the U factor as well, and the solar heat gain coefficient. Understanding standard window sizes will help estimate window quicker, and most homes will typically have 1 to 4 different windows, where the windows are typically the same size, same construction material, usually bought at the same time and then installed. So once you have one window, it may be the same as 10 windows within that home and make that process a little bit simpler. Bathrooms and other spaces may have unique windows, or basements may have slightly different windows designs, but for the most part, majority of the homes have very limited different size windows. Know how to assess the windows. For that, make sure you first look at the NFRC label. Coming to my house, you're going to get one. Typically, most people don't save those. They're scraped off the windows, tossed away, and the homeowner doesn't know how to really look or understand where to find that information. Windows do have that etched on some windows within between the window panes, so you could find an etching, go look that up, and that does prove difficult sometimes, even going to manufacturer websites. But that is crucial to try to get that information and really find it. Get the U factors. Model numbers for the lookup, typically either etched, like I said, or stamped in between the window panes. And then if you're having a hard time with that, U factor ranges, and these are a little conservative. Single pane is 0.49 to pretty high above 1, essentially allowing essentially just allowing heating to move past it as if it's not there. Double panes per building codes have been updated to be more strict, but traditionally in the past, the 0.40 was a decent number. Double pane windows with low E coating can get even lower, and they can actually nowadays get as low as 0.2. So it is important to make sure you have those numbers, since those will impact your heating load. Also with windows, know how to assess the window when it comes to counter the panes. You can look in between and see the spacers between the panes to really know if it's a single pane, a double pane, or triple pane. Note that the framing, or what type of framing material it is, whether it's aluminum, wood, or vinyl, or fiberglass. Know your glass types. Clear glass, likely. If it's a pretty old home, 30 years or older, and hasn't been in any updates or renovations to it. Most windows in the Northeast are typically built with low E coating, and that is more common throughout the area. And then there's reflective glass, which is if you're standing on the outside and looking at it, you would see the glass reflecting an image back towards you. Other techniques to determine if there's a low E coating is the double light, where if you use a lighter, you could actually see multiple images of the flame across the low E coating. Okay. What matters most when you come to the above grade walls? Wall area is an extremely important factor, especially when it comes to walls with windows in it. So make sure you do good wall area measurements. R-value insulation, and then insulation thickness within that wall. In residential small commercial construction in New York, the more common above grade walls, construction type is wood framing cavity, typically 2x4, with vinyl siding on the outside. To get a good measurement, you can measure across a door jamb. That will give you a pretty close estimate to thickness of the wall, or across the window. With that, make sure when you do it, do not include the trim area. The trim area will stick past a little bit and add to that measurement, but typically around 4 to 4.5 inches is your wall thickness on a 2x4 if you're measuring across the door jamb. And then typically wall studs are 16-inch on center. 24-inch on center is allowed for 2x6 studs or metal frame studs or bigger, but 2x4 is 16-inch on center, so that can be easily looked at. If you find it's a 2x4, it's going to be a 16-inch on center measurement.
Hey, quick question, unless you want to wait till the end.
You can ask now. Go ahead.
Okay, cool. Yeah, so on that window glass page you had, and you're talking about the lighter, is it true that the color flame that you see in the reflection would indicate what kind of gas it's filled with too?
I do not know that. That's interesting. I would have to look that up and come back to you on that.
Sometimes it's green or
Yeah, I would have to look that up and get that back to you. That's interesting.
Do you know, Marcy?
Usually you can take a flashlight and shine it into the window, and if it's double pane, you'll see the two reflections, but you might see a small green or a white reflection in the background. If it's green, it's usually low heat
Okay,
coated.
cool,
If it's white, it's clear.
right on.
I mean, that's kind of like a.
Right, but that's telling you the low E, not the gas
Yeah, it
filling.
doesn't tell you the gas.
Yeah.
Cool, thank you.
So maybe that's where the color's coming from. Interesting. Appreciate it. Thank you very much. All right. I'll take interruptions any day. All right, so cavity insulation, common types. There is a lot of insulation. There's fiberglass bat, that's traditional. It's still used a lot today. High density cellulose that gets better with R values of 3.2 per inch and continue to improve. Spray foam, polyurethane foam is even better. They can even get 3.7 and all the way up to 6.0 for an R value on those. So you're looking at 2x4 to 2x6 studs where the fiberglass bat, you're going to probably be typically R11 to R15. And then with the 2x6, you're going to be R17 to R23, and you can get all the way up to R33, R31. So it is extremely important to measure a wall thickness and to understand what insulation is within the wall. Okay, so wood frame, interior board insulation is uncommon in the Northeast and cold climate regions. Exterior board insulation is much more common, likely exists for homes with the 2x4 wood frame walls. And that's 2010 or later, and that's because of the changes to the efficiency code and building codes. As that went forward, the construction can still be 2x4 with an R13 insulation, but you have to meet the efficiency code and add an R5 continuous insulation exterior board to the home. And that's where that came from. And the easiest way to determine this, or a good practice to determine this, is if the window is actually recessed further back off the front edge of the home, a little bit more than an inch or so. That means that if you have 2 inches, they did put in an exterior board insulation. Okay, so what matters most when it comes to the below grade walls? So same thing as above grade wall area first, and then the R value, insulation depth, and then below grade depth. Half a wall being above grade for a below grade building is going to provide some type of heat and cooling gains. So make sure you put that in correctly for if it's a split level or a full basement. And even on full basements, they may still have some parts sticking above ground. The other part, look for what type of masonry walls there are, whether it's poured concrete or brick, block, and so forth. And then really understanding what type of basement it is, whether it's finished or not. And that will also provide more information on the Manual J. Common basement insulation types, and that will also range, as we discussed earlier, with the above grade wall insulation. Okay. Cavity and continuous insulation. Unless you're there for new construction or a heavy retrofit and renovation and you were able to see this, some of it may be tough to tell if it has a continuous insulation, but it does exist. Continuous insulation, interior to brick wall, has been used before and could be a possibility. So this is why it's crucial to really get the construction details on a building. So moving on to ceilings and roof. For ceilings, ceiling area, types of insulation, R value, and then the installed insulation thickness. And as you can see, most of these are very similar between any type of area that has internal insulation within the studs. Identify the building envelope, ceiling roof styles, what type of roof it has, whether it has a insulation along the roof deck or within an attic space, but it is important to make sure you catch that. The flat ceiling, vaulted ceilings, how air moves through that space is affected by that and does impact the Manual J. Within attic space, common attic insulation, similar to the previous installation slides that we did talk about, and with similar R values. Tips and tricks for insulation, different ways of measuring this. For a bat insulation, typically you're going to see printed on the bat itself, and you can look at it. For loose blown in, you can do paper measuring tape or measuring tape across that and see how deep it is. And then for the polyurethane foam probing down a single point to the depth and trying to get that full depth. Use a small diameter wire or something to really get into the down to the ceiling drywall gypsum board. So what matters most when it comes to floors? The floor area definitely matters. Make sure you get that correct. Type of floor, whether the home is losing heat or gaining heat through the ground. So that's slab on grade, below grade, above basement, crawl space. If it's an open crawl space, insulated crawl space, things like that, conditioned and unconditioned. The assembly R values on that, perimeter and or the under slab insulation. Under slab insulation may be hard to get without construction detailed, so that you should at all means try to get it, but may not be able to because of that. It is important to make sure you have the correct framing material that is used within a building, whether it's wood, steel, so forth. For framed floor adjacent space modeling and variables, make sure you capture that this floor is jutting outside of the house. This is exposed. This floor should be insulated per best practices and some building codes, but make sure you double check to make sure how far that is, get good measurements, and what type of insulation is installed in there. Framed floors over garage and basements and outside. For that type of building, this best practices and building codes require this to be insulated and separate this upstairs from the downstairs, but once again, make sure that is correct and get that measurement so you understand the R value for that space. Okay, so here are a few tricks with how to really get into that. You can remove a floor register, see how deep the floor is. See if it's a 2x8, 2x10 joist. Remove receptacles, remove the receptacle and look into spaces to see if it's actually insulated. And then conduct a building plan review for the architecture engineering drawings. Okay. Common framed floor insulation types correspond to the average R values per inch, and the fiberglass is traditional 3.3. There is cellulose dense pack of the 3.2, and then what we're now seeing in today with the spray and closed cell polyurethane of our 6.0 in crawl spaces. And a lot of this is hard to find and check unless you're really looking at the documents for construction on the next couple parts for the floor slabs. But these are where they're at, and they are important to grab this information and really understand that. So make sure when you're doing this, pay really close attention, and if you can see it and get that information, it is very beneficial. So what matters most when it comes to slab on floors, slab location, on grade or below grade, perimeter insulation levels, perimeter insulation location, interior or exterior, under slab insulation, and then there may be visible signs of perimeter insulation after the slab is poured. Consult a building plan if available, and then have a conversation with the homeowner and if they were there for construction or if they've done renovations. Common slab insulation types that correspond to average R values. Extruded poly with an R5, the poly and closed cell poly are a little bit better with an R7, R6. Doors, what's important with the doors? Area, material. door cores are important. So since typical doors are wood panel or fiberglass, small portion of that is actually glass. The way the calculations model. So this is why the doors are not a high priority, as Chrissy said earlier. And then in load calculation software, doors only refer to exterior doors that contain less than 50% glass. If it's a solid glass door, it has to be entered differently. So these doors are less than 50%, some type of wood, metal, or polycarbonate design, cored hollow doors. How to determine ventilation CFM. Look for the CFM sticker. Look it on the nameplate of the fans, ERV or HRV. Multiply the fans rated CFM by the schedule intermittence, so if it turns on and off. Fans may operate on a timer, 30 minutes on or 30 minutes off, so there are different designs for that. And then key, a bathroom or a kitchen hood does not count as the ventilation for design ventilation of a building. That should not be used within that entry field on the manual J. Exhaust only ventilation is one type of ventilation where you just pull air through the house. Balanced ventilation without recovery uses both, or is supplying and pulling air from the house with returns and supply grills. And then the conditioned air can be conditioned through an ERV or an HRV. The ERV does help with incoming and outgoing air to warm it, and then an HRV does the exact same thing, and it does have some moisture transfer on that. So determine if the unit's recovery efficiency through the nameplate data, and then recovery for the efficiency should be is typically 70 to 90%. Okay. And then only applicable for ducted systems on this part. So duct losses should not be included in the low calc for ductless heat pumps. Duct losses should be included for load calc for existing ductwork that's being reused as part of a retrofit, new duct installation, and then any duct that are outside of the conditioned space. And then what matters most when it comes to ductwork load calculation, location of the ducts, whether it's within a conditioned or unconditioned space, whether the ducts are properly sealed, whether the ducts are insulated, and then the function, supply or return side of the ducts. You do not need to know the duct run lengths for heating and cooling load calculations. Okay. Typical duct location software inputs is conditioned or unconditioned, and this is actually how it treats it. Ductwork in unconditioned space is what impacts heating and cooling loads, and it's pretty substantial. You can see a large change in the manual J because of how this is displayed and entered. Unvented attics, vented attics, those are traditional unconditioned spaces, things like that. If it's outside the thermal envelope, it is considered an unconditioned space and should be treated as such. Okay, so what impacts the, what to inspect when you're looking at ducts? Inspect the supply and return plenums, make sure those are connected correctly. Inspect joints and connections. Make sure you see the duct mastic and UL 18 or 181 tape. You should never ever see duct tape on ducts, ever. Please don't do that. Okay, how to select the tightness category. So when a building is looked at for whether it is average, loose, or tight, and there's a in-between phases on that, conduct the duct leakage test on it, use a duct blaster, and then the second one is select tightness category within the manual J. And those range between the unsealed, partially sealed, average, and then notably or extremely sealed, and a lot of values associated with that. Okay, components of most common scenarios within that, internal gains, add to the heat in the space and impact the cooling heat. And then occupancy is typically number of bedrooms plus one person. Okay. And then the ACA Manual J does have a table that is set up for that. And I am going to turn back over to Chrissy to close us out.
Okay, so that was a lot. But after you've done all that work, done the load calculation, whether you're having one person and your whole team doing the load calc, or you're having a couple people, it's really good to kind of check each other's work. So we came up with a list of Manual J don'ts to make sure you're, not oversizing your heat pump. So one, don't add any additional safety factors. There are already safety factors built into most softwares. They estimate about 20% oversizing is already built in. Do not design for record weather-breaking conditions. Yep.
So regarding the safety factors, when Manual J was written, there were no heat pump water heaters. Heat pump water heaters represent 16,000 BTUs draw in space for heating capacity. So with the heat pump water heaters in the conditioned space, we model that as a heat sink.
I would say you'd want to consider that as part of your load calculation.
It's a Frank to throw him a zinger.
Yeah.
I mean, if you have that data and information, you should try to model it.
Yeah.
If it's pulling heat from the building. I mean, what do we traditionally see for basement cooling on, if I have a basement with a heat pump water heater in it, how much cooling is that actually providing to that space? And then is it pulling enough air from the rest of the home through the basement to actually cause a difference?
That is a part of the conditioned space, that impact.
Well, that's what I mean. Like, is it pulling from the conditioned space through that?
I was on a webinar once where they brought that up, and somebody did throw out a number for that, but I just don't remember.
Yeah. But those,
Actually, I helped make this heat pump water heater guide for the Energy Star Next Gen new construction program. And in there, I don't remember the number off the top of my head, but there is a number in there that gives you an estimate of how much BTU output it's going to give. So take a look at that number, and that should help. But I would say, yeah, if there's going to be a heat pump water heater, you want to consider that in your load
Agreed.
calculations.
I've seen both heat pump water heaters with the output ducted through the rim joist outside, so the basement wouldn't be cooled down, especially in winter.
Yeah, if it's not going to be part of the conditioned envelope, and it's not going to be
Right.
impacted by what the heat pump's putting out, then
so
you
for,
wouldn't.
Even so that's still heat sink.
yeah. So it's, if the heat pump is installed
Mm-hmm.
and just takes suction and discharge off of the room it's installed in.
Mm-hmm.
If the heat pump is installed, takes suction off of the house but discharges outside.
Right.
And then they have heat pumps that are installed that take suction from outside and discharge outside. So understanding what type of source that is, because it can change it from being a heat sink and turn it into a heat source because it's going to have more heat within that space. So really understanding that and getting that information. And then, as Chrissy said, take a look at the Energy Star new construction to get the value. Thank you for the question. I appreciate that. I didn't even know that, and she wrote it.
Yeah, we're seeing that in some multifamily buildings, being installed in conditioned space, and it doesn't appear that a lot of the load calculation software has a way to account for it clearly, or in like a default way, which would be really helpful
Okay.
to understand like what that value could be.
Okay.
And of course, it'll depend on like usage and things, so it could get really complicated.
Very true.
Just having some standard would be beneficial.
Okay.
Or best practice too for installing them in conditioned space, because it may not always be appropriate to do that. Or ducting, there's lots of options, but it is something we're seeing more of.
Yeah, it's always going to have some impact because in a cold climate region, you're never going to like take intake and exhaust for heat pump water heaters in our climate. So Yeah, no, that's good. All right, I'll think about that.
You're on
Any
the
other
second one.
questions? What?
You're on the second one.
All right. Do not design for record weather breaking conditions. Like we talked about, use the ACA or ASHRAE 99% dry bulb temperature for heating and 1% dry bulb temperature for cooling. Do not reduce known ceiling, wall, or floor R values. What you see is real in the home. Do not include walls, ceilings, or floors that separate condition spaces in the load calculation. So you have a floor or a wall and there's condition space on either side, you're not going to put that in the model. Do not assume ducts are not sealed or not insulated. Give fully sealed and insulated ducts full credit. Yep.
I have a question, sorry, back up to number 3 about reducing R values. So if you go up in the attic and you see insulation up there says R30, but it's installed really bad, that will derate the effectiveness of that R value.
Correct. So what you see is real. So that should be.
That would be a reduction from that R30.
Right, but you're seeing that it is not installed correctly.
Right.
You
Right.
should not put R30 in as that.
Okay.
So
Yeah.
what you see is real, is the point. Like, if it's messed up, please don't put in.
Yeah.
All right.
All right. Do not fail to give full credit for a builder's effort to produce a tight envelope. And do not use manual J for commercial or large multifamily applications. That requires manual N. All right, so these are just some sanity checks. So look at these as if like you're cross-checking your coworker's load calc and you're just, you haven't done much with the home, you don't know much about the home, you're just doing some quick sanity checks, and these are going to lead to some additional conversations with that person. So check homeowner name and address information are accurate. If you don't know anything about this home or the square footage, maybe a quick check would be, okay, is this square footage within plus or minus 10% of real estate websites? If it's not, then you'd have that additional conversation. What's the difference here? Confirm number of stories. Outdoor design conditions used are based on ACA Manual J tables. Indoor design conditions used should be based on ACA. So heating should be 70 degrees. Cooling should be 75 with a relative humidity of 45, 50, or 55. You shouldn't be putting in inputs based on that homeowner who wants their house at 85 degrees. You should be doing it based on what the standard requires. Do a quick sanity check about balance of heating and cooling loads. So in cold climate regions, usually the cooling load is going to be half to a third of the heating load. So just do a quick check there. Most softwares will calculate a % heating load of each component if not already done. So double check to make sure that each component of the home is, within these reasonable percentages of the total load. So you might have smaller or larger values, that is possible. But again, this is just like, okay, sanity check. Are the windows and glass doors within 15 to 30% of the load? Above grade walls within 10 to 30, below grade walls 20 to 40, ceilings 10 to 30, infiltration 5 to 30, doors only going to be a couple %, and ventilation 5 to 30. Again, percentages depend on the climate and type of construction, but these would just be red flags if anything's out of range. No load counts for adiabatic surfaces, we already talked about that. Glass area is typically 20% or less of the conditioned floor area. Any skylight area shouldn't really typically exceed 5% of the conditioned floor area. Another quick check is confirming wall surface areas are accurate. So you can multiply the perimeter length by a typical 8 to 10 foot ceiling height. Check ceiling area total and floor area are close. You're gonna have a pitched roof, or if it's really pitched, maybe that's why it's off. But typically the ceiling and the floor area are gonna be pretty close unless there's multiple floors. No duct losses for a proposed ductless heat pump system. We have seen that actually in a certainly number of times. So no duct losses for a proposed ductless system. All right, let's just talk about software programs real quick. So software is a powerful and useful tool, but it is not magic. Load estimating software tools do not always do what Manual J stipulates. And all software products have built-in defaults. And those defaults can have a real impact on your results. So if you're not using Manual J software correctly, it can produce an inaccurate and misleading answer. So it's really important whoever is using, doing load calculations, that they have read through Manual J, understand it, and understand that how your software that you're using, the inputs you put in, are gonna come up with some built-in defaults. So we did a quick test just to see how, we wanted to check this out and see if this is true. So we compared two different softwares. I won't tell you what they are, but you can't really see, but these are all the inputs we used for the software. There's only a couple small differences: above grade total wall area, 1876, 1894, and window total area, 261 and 234. But we tried to get as close as possible as we could when using these. Ducts total heating load, 6,600 for software A, 6,451 for software B.
Are these assumptions?
No, yeah, so these are, so we wanted to test out if I design the same home in two different softwares, how are the results gonna come out the same? Or are they gonna be different?
One's both Manual J software.
These are both Manual J
Yep.
software with the exact same inputs.
Yep.
The software is doing the calculations and giving us
Like white soft versus cool count, something like that.
something
Yes.
like that.
Something like that.
Was it any of the LiDAR software or just the?
This is random software. This is just two random
We are
software.
not biased toward any
We are
software.
not going to pick a software and tell you what software we use. Two random software.
Why weren't you able to have Windows area be the same?
It's like some of the built-in defaults kind of,
Yeah.
The assumptions.
Yeah.
Okay.
The assumptions will cause issues
So
within
in
the.
that case, that was an assumption of a certain percentage of the house and not, I'm trying to decide which up there you entered, the data you entered, and which was the assumption. You're saying that all of this was the assumed data from the data you entered about the house. Is that accurate? So everything we're seeing up there was what the computer spit out as a default?
Yes.
yes,
Okay.
yes. Okay. So, software A came out with a total heating load of 33,000. Software B came out with about 40,000 BTUs per hour. And then total cooling load, software A came out with about 21,500. Software B came out with about 19,000. Yep.
Yeah, I was gonna ask about this, so I'm really glad you guys got into it. I've noticed that, default values for air sealing between different Manual J's can tend to be vastly different and come up with, up to a ton
Right.
difference in terms of sizing. But also manually entering it in. It just seems like some Manual J's actually will weigh air sealing a lot heavier than others. Up to like a whole ton worth of sizing. That throws me for a loop. Like when you manually enter it in, you'd think that anything that's ACA certified would be across the board putting out the same numbers. And that's air sealing specific values, right? So that's what I found to be what throws it off.
Okay.
Like in the, you get a little breakdown of where BTs are coming from where. So even when manually entering it, I've seen that. I don't know if you guys have thought that or run into it.
I mean, we're just finding the ones that where you put the least amount of inputs in are going to put out the most oversized equipment. It's going to build in that additional safety factors.
See that a couple more times.
Relying on defaults within a system is
Yeah.
going to extremely oversize your heat pump.
Right.
Guaranteed.
So, and that's why doing a blower door is so critical. So you can, not have to rely on that semi-tight, loose, average, those defaults. Mhm.
Which is, I guess, as a follow-up question too, with like, is there a standard value? I don't know how to ask this question because I get too wrapped up in details. So like if I put in something's like 10 ACH, okay, we'll use that as an example, like a manually entered air sealing value. I would consider that pretty close to average, right? And maybe that's me being wrong, by making that assumption as being average, but then if I put in average as the default, it sizes it a lot lower than I would expect it to by just going, which I know what you guys just said, if you go by the defaults, it will oversize, but I've seen the opposite happen too, comparing it against the defaults and actual lower value. So maybe I'm just assuming 10 air changes per hour is, that is an average, right? So,
Well, if there's this type of variance between two softwares, it's possible that other softwares are making assumptions in different directions.
Correct.
So
They can. And the depending on the software and building codes, right? Because right now building code's like 7.5 ACHs, which would be your average,
yeah, that's kind of where I was trying to figure out.
which may be another assumption, and that's relying on whoever did the software and what they use. So like we wouldn't be able to answer that. We're just showing that just be careful of the software you pick.
Yep.
And make sure you really understand that software, because the software is going to give you a different answer than someone else's software.
Yeah.
So really understand that.
Right on. Cool, thank you.
With that being said,
Yeah.
we are at the end and like
Okay.
to close out. Thank you very much for everybody. And thank you very much, Chrissy. And we do have additional information that do provide technical support. We do have some duct sizing or duct evaluation material. We really wanted to help the contractor assess ducts, so that does exist. Air source heat pump oversizing, overzoning, multi-mini split, pros, cons to both of the systems, whether you're using them.
Yeah.
And then other technical resources located on the Clean Heat Connect website. So please feel free, it is free for use. Have at it and use as much as you can. Thank you, Chrissy.